Okay, students, today is lesson 19.2, understanding quadratic functions of the form g of x equals a, in parentheses x minus h squared plus k. Notice the only thing being squared is the x minus h, so the a is not being squared. So they want us to start off by graphing the parent function. Parent function is this guy right here because nothing is happening to it. All we have is an x squared. You're not adding, subtracting, multiplying, or dividing anything to it. So here we go. Let's go to Desmos. And if I graph the parent function, voila, there it is. Okay, how do I know it's the parent function? Few things. First of all, I notice right here is the ordered pair 0, 0, and it is a minimum. If I were to take and draw a dashed line and cut this graph in half, I would have my axis of symmetry happening at x equals 0. Half of the graph is here on the right side, the other half of the graph is here on the left side, and what we have here is something called symmetry. Each point here is the same distance to the point here, except in the opposite direction. All right, so the first thing they want us to do is to stretch the graph vertically by a factor of, and they don't tell us, to obtain this graph. Well, you notice that a is equal to 2, so we're going to stretch it by a factor of 2. So I come over here and I say, all right, well, let me do it. So 2x squared. And you'll notice my green line, which is my 2x squared. My green line is actually being stretched together closer. So it's on the inside of the red lines. If it was on the outside, we would say that's a compression or a shrink. Okay, so now it says, hey, notice that this point 2, 4, and I'm going to come over here and I'm going to do a quick table because I want to see where 2, 4 is. 2, 4. 2, 4 was originally right here. Okay, now I'm going to do this real quick because I want to take this off. Okay, I don't want to step by pi, I want to step by 1. And I'm only interested in pretty much 10 to 10. Actually, I should probably change it to this graph, 6, 7. So let's go -7 to +7. And then what's my y? Let's see, I go from -5 to +11. So -5 to +11. There, now it looks more like the graph that I need, except for one last thing. I want to take off minor grid lines. Okay, now, a little bit easier to see, I hope. There you go, that's better. Okay, so now the question is, where did point 2, 4 move to on the green graph? Well, you notice if I go to 2 and I want to go to the green graph, I have to go all the way up to the number 8. So if I check it, 2 went to 8, sure enough, it lands right on that graph. So I'm going to come back over here and I say, okay, so it moved to 2, 8. Notice what didn't change and notice what did change. The input, which was the 2, the independent variable, only changed the output, which is the y, the dependent variable. Remember, x controls y. So you still plugged in 2, and this time you did 2 squared, which was 4, and 4 times 2 is 8. So now what it wants us to do is it wants us to translate this graph, or 3 units, up and 1 unit to obtain the graph. Okay, so here we go. We're going to translate this unit, this dot, 3 units up, 1 unit to obtain the graph of 2 times x minus 3 squared plus 1. So now what I want to do is I want to graph this guy and see what changes happens. So I'm going to come over here. Let's get rid of these dots because I really don't need them right now. And now I want to leave this guy alone. And I want to do 2 parentheses. My fingers aren't big enough. X minus 3, close parentheses. This time I want a squared. And then I want a plus 1. Now notice what happened to my graph. Okay? They want to know now, where did point 2, 8 move to? Now let's bring back point 2, 8. So point 2, 8 was right there. And it's on the green graph, which both of these are greens. That's kind of stupid. So what I'm going to do is I'm going to change this color. Change it to, I don't know, I already got red. Let's change it to orange. Purple. Okay, purple's better. Okay, so now I want to know, where did that point move to? Well, in order to understand where that point moved to, it's easiest if we look at the vertex and follow the vertex first. Now, that means the vertex was originally at 0, 0, which was right here. Now, you'll notice that I wanted to move 3 units, right 3 units, 1, 2, 3, and up 1 unit. So it moved right there. Okay? So it wants to know, where did this one move to? Well, it still moved 3 units, 1, 2, 3, and then it went 1 unit up. So looks like it's sitting at 5, 9. So I'm going to come over here and confirm that it's sitting at 5, 9. So let's do 5, 9, and sure enough, there it is. So I'm going to come back and I'm going to say, well, this one moved to ordered pair 5, 9. Now, how did that happen? Well, did you notice it said move 3 units to the right and 1 unit up? Okay, now look closely right here and see if you can make sense of that. I wanted to go 3 units to the right and 1 unit up. And let's go to 2 and 8. So if I took these two and added them, guess what I get? Sure enough. So now it wants to know, okay, so where's the new vertex at? So the new vertex, remember the vertex was this ordered pair right here at 0, 0, and it moved to right here. So this new vertex is located at 3 because we started at 0, 0. So here we go. We started at the vertex 0, 0, and we added 3 units up and 1 unit over. So my new vertex is located at 3, 1. So I come over here and I say my new vertex is 3, 1. Okay, well I'm sorry, I put that on the wrong spot because I got excited. The original vertex was at 0, 0. And the new vertex is located at 3, 1. Because again, we went 3 units to the right and 1 unit up. So every single dot on that parent graph and that green graph, actually every single point on the parent graph moved 3 units right and 1 unit up.